Hi geometry friends, here we are finding ourselves in chapter 4, section 4.5, and we're going to be talking a little bit more about proving triangles congruent, but this time we're going to use the angle side angle postulate and the angle side postulate. So as we come down to our vocabulary, our new vocabulary, very similar to the vocabulary we had in the last section where we were talking about included angles. Now we're going to talk about an included side. And so this would be an included angle, but an included side, let's see if I can get that picture together. So an included side would be a side that is between two specific angles. So before, remember when we had an included angle, it was between two specific sides. Now an included side refers to a side that is between two specific angles. Not too hard of a definition to remember, especially since it's pretty much in the name. Let's go ahead and look at some of these postulates. The first postulate that we'll look at today is the angle side angle congruence postulate. Angle side angle basically says if you have two triangles and you can prove that the angle and side and angle of one triangle is congruent to an angle side angle of another triangle, just in that way, it has to be the included angle between those two angles. If you can prove that those two things are equal, then by ASA you can prove that the two triangles themselves are congruent. I said equal. If you can prove that these parts are congruent to these parts and they go in that right order, then you can prove that these triangles are congruent with one another. So here in this first example, we're given an opportunity to demonstrate our understanding of the angle side angle congruence postulate by doing a two-column proof based on the information here. So let's go ahead and get started. So we see that QS bisects angle PQR. So that's not a hard leap to say that angle PQS must be congruent to angle SQR or RQS, right? So I'm going to just mark that as something that I kind of know or I can easily glean from the given information. And then the next bit of information they're going to give me is that PSQ, that's this angle here, is congruent to angle RSQ, this angle here. So I will use double curve marks here on this angle to say, okay, this is some given information. Do you already see the angle side angle situation that we have? Hopefully you see that these two triangles, PQS and RQS, share a side. And this side is going to be the included angle, and that's what we need to prove these two triangles congruent. So let's get started with our proof. The first thing we should probably do is write down this given information, then we'll write this given information, and then we will lead it over to the idea that angle PQS has to equal RQS by definition of angle bisector. What I'd like you to observe is that I literally just wrote down the bits of information that I was given in the given, and this third step is going to lead right from number 2, which is that these two angles are congruent to one another. So there it is, angle PQS is congruent to angle RQS, definition of an angle bisector. One little caveat, I'll be honest, I might be jumping the gun a little bit. I could have said the measurement of this angle is equal to the measurement of this angle, definition of an angle bisector, and then gone on to say that the two angles are congruent to each other, and then that's definition of congruence. But I'm leaving that out because that's a little bit too much for the space that we have, and I think you get the idea that if angles have equal measures, they are also congruent. All right, so with that, we're going to do maybe one more step before the finale, and that last step is that SQ is congruent to itself, right? SQ is equal to itself, and that's the reflexive property of congruence, something like that. So I'm going to put reflex prop of congruence. All right, so with that we have all the pieces that we need. Now if you want at home, you can do a drum roll. We can say that triangle PQS is indeed congruent to triangle RQS, and the reason why we have this congruence is by the angle side angle congruence postulate. Thank you. So this one, if you notice, is not a postulate. It's not something we're just going to hold true. This is something we can prove because it's a theorem. And this theorem is called the angle-angle side congruence. And it really is important for you to look at the order in which this happens. So if you have a situation where you've got one angle and then next to it another angle, and just after that angle a side congruent with same situation or same consecutive way, an angle, and then another side right after one another, then you can say that the two triangles are congruent. Let me break it down a little bit. So let's say we had these angles being congruent to one another, and then instead of this side, let me change the side. Let's say instead of this side, EF is but congruent to AC. Would that be an angle-angle side situation? Would that be an angle-angle side situation? I am here to say it would not. It has to be in the exact same order. So I hope that makes sense. It has to be angle-angle side, and same situation, angle-angle side. And the angle, I know I'm sounding crazy, y'all, but angle-angle side, and then this other guy, let's say angle-angle side. The angle that we're referring to here has to be the same measure as that angle, and the angle that I'm referring to has to be the same measure, and this side has to be the same measure, and it also has to come consecutively after this angle. Are you with me? So that's really important. You want to make sure the order is the same, but basically it's like angle side angle without the angle side angle. It's angle angle side. So here we are in example 2, and we're going to use angle-angle side to prove that two triangles are congruent. So let's take a look. We're going to do my favorite 2-column proof. Let me set that up. Perfect. And then let's go ahead and analyze what information we have. So we are asked to use angle-angle side, and we are told that this angle, DAC, let me highlight that, DAC, this angle right here, is congruent to angle BEC, BEC, that's one here. And we are also told that segment DC, from here to here, I'm going to draw a line over that just to keep our eyes focused on what we're dealing with. BC is congruent to BC. I said BC, but DC and BC are congruent. And so I actually, this is not the first time I had to redo this video a little bit, because I was looking at this, I'm like, why are they asking us to do angle side when clearly we can just pull this angle in the mix, right, and say angle side angle to prove that these two triangles are congruent. And it took me, I got a couple steps in and I was like, oh, I see what it is. We can't do angle side angle because this is angle, but this is not the entire side. Right? This little bit that they gave us, this BC, is not the entire side of triangle ACD. And this little bit here, DC, is not the entire side of triangle ECB. But DC is part of ACD and BC is part of ECB, so we can use it. It's a little hard to see just because so much stuff is here, but what I want you to observe is that we just don't have enough information quite yet. I'm going to just highlight one of these triangles that we're dealing with. We don't have enough information to do angle side angle as I want, but we can do this angle side. You see, this angle, if the fact that two pairs of angles in two separate triangles are congruent, then the third one's automatically equal. Remember that from the last section? So then what we can then say is, I gotta say this, I can then say that this angle here that I've got in green is congruent to this angle here. This is where I'm going with it. Let me use two marks just so you don't think that I'm trying to say that they're equal to each other, equal to these guys. So these guys are equivalent, and what that gives me is now I've got angle, let me see how I got it, give me a second. I've got, if I'm looking at, so I'm going to stay with the highlighted triangle BEC or ECB, whatever. I've got angle, okay, start here, angle side. Do you see it? And then over here I've got angle side. I don't know, pause it and look at it. It's kind of a weird thing because I got tripped up too. So I'm going to write this proof from that perspective. So let's do it. Just going to write down my givens. There's one and there's the other. The next thing I need to do is confirm that this angle is equal to itself And I'm saying that just to say, hey, the same angle is equal to itself in two different triangles, right? So that's the reflexive property of congruence. That's why angle C is equal to itself. And now I'm going to talk about that theorem that we had last time, which was the three-angle theorem. And that told me that because I have this and this, two pairs of angles in two different triangles congruent, then the third angle must be congruent. So there we go. I've got that third angle theorem. And now I have all that I need. I've got the angle. Remember, we were going to go like this. We've got angle, angle, side, and then angle, angle, side. All that information has been confirmed here. And so now I can easily say, or truthfully say, that triangles ACD and triangles ECB are indeed congruent. And we can say that by the angle, angle, side theorem. All right, not too shabby. Before we go, let's just do a quick review of the different ways that we currently have to prove that triangles are congruent. So we've got the SSS postulate, SAS postulate, ASA, and the AAS. All right, so keep these in mind as we continue to move forward and prove triangles congruent. Let me know if you have any troubles, questions, comments, concerns. I'll happily talk to you about them, and I look forward to seeing you soon. Take care. Bye-bye.